I'm really excited to be talking about Vibe NLP today. And just as a quick intro, some of you might know me from my work on Spacey. There we go. Spacey is an open source library for industrial strength natural language processing. So it was really designed from day one to be used in real products and in real projects. And we've also always put a lot of work into kind of the boring stuff of open source maintenance, like making sure we have backwards compatibility, not breaking people's code. And that had a pretty nice side effect more recently, which is that LLMs are actually really good at writing Spacey code. So that was very satisfying that unexpectedly this all paid off. And we also developed Prodigy, which is a modern annotation tool designed for creating data and developing data for machine learning specifically. And it's also very Pythonic and is fully scriptable in Python and extensible. So if you can do something in Python, you can use it with Prodigy. And so overall, we have a lot of very powerful tools that we've built over the years. And the biggest problem has always been, how do we make it easy to put it all together and actually use them to their full potential? Because the hard part has always been, especially about NLP, deciding what you want to do in the first place and how to break down bigger problems into the components that you can then train, annotate, and so on. And the actual training of the model is kind of just the tip of the iceberg, really. And that's kind of what I want to be talking about today. And it turned out that one of the big missing pieces that we've been looking for all these years were really coding assistants. And AI coding assistants have really transformed the way we develop software. I used to do on this point like a show of hands, like, oh, who regularly uses coding assistants? But I don't even think that's necessary because I think we've all been at least dabbling in Claude Code, Codex, Copilot, and so on. And whether you're just like developing vanilla Python, need some grunt work, need to implement something, they can really help you implement code for any given tool that you might be working with. And also, especially more recently, they've also become much, much better at picking the right tools for a specific use case. So you don't even need to decide what library you want to use. You just describe your use case and especially also your business problem, and the coding assistant will pick the right tools for you and decide how to implement it. And that really lets you solve these real-world problems, like, for example, you need to analyze some documents, you attach them, and then you want to create some table to, for example, list different types of IT spending over time, and you will probably get a good, reliable piece of software out of it, maybe using something like Pandas, and your problem is solved. And now you might be thinking, well, that's all like really cool, but aren't the models getting better and better? And will we even just need to write code anymore? Like, can't we just instead ask the model to just solve our business problem instead of writing us a script that can do that can solve that problem? And I think a lot of this, as LLMs have developed, it's kind of very obvious that these models are powerful and there's a lot we can do with them, but it's been a bit less obvious how to really harness that power and how to integrate that into our workflows. And I think a lot of it really comes down to how these models work, because they always generate a continuation of the text. And that's usually somewhat correlated with the answer and what we want to get out of it. And but these continuations aren't necessarily the best way to access that knowledge that we're after. This example that I have here is particularly confronting because LLMs don't have access to the character level representations. So tasks at the character level are actually unexpectedly difficult. So even today, a task like reverse these strings, that is something that even models now might be struggling with, especially for rare words. And so if you ask it to reverse a string, you kind of have to wait what the model produces, and every time you get an answer, you need to check if it's correct. There's a high chance that it might not be, and you don't know whether it's going to be right until you see it and work through it word by word. And instead, of course, you could ask the model to transform that prompt into a program and write a script to extract, reverse these strings, there I am. To transform the prompt into a program. So that's only really one transformation that you have to be doing, and if you do it right once, you can then check the result and you can run it over and over. And that seems like, overall a much more reliable and practical workflow. And this doesn't just apply to tasks that the model is inherently bad at, like reversing strings. We can also use the model to do things like extract all company names from the text. And then, it'll probably, if we ask it to list all company names directly, it'll probably do pretty good at that, but we can also write a script to let it do the same. And it might pick a library like Spacey, for example, and this means that we only really need to use the generative model that can be large and slow once to create the script, and not for each document that we are processing and extracting information from. And when it comes to LLMs, one common vision is this kind of one model to rule them all idea, or what we've also called LLM maximalism, like one model that's so good that is really all we need and that can solve all the problems. And this is also the big promise of AI, and also what's kind of been sold to us by big tech and, of course, LLM companies. So instead of traditional software, the LLM itself becomes the system. But is that really the best way to do this and really the best workflow? I actually believe that there's a different and better way to look at it. And instead of using LLMs as the system, we can use them to build the system. And this means that even seemingly complex tasks that require custom machine learning components can be solved by using LLMs to build the solution. For example, instead of using a large generative model at runtime to sort your text into categories, you can use it during the development stage and use it to create data and train a classifier for custom categories. And the result that you're getting here is a component that can be much more accurate, fast, of course, small, data private, because you can run it yourself, cheap. That's especially something, I think nowadays people are paying more attention to how expensive the LLM calls actually are. And also a very transparent solution that's modular. You have a component that just produces one thing, so it really fits into common software development best practices. So if this is all so great and so good and so much better, like why are we not doing more of this? Why are we not just building more classifiers? And I think the problem is that a lot of the ideal workflows are really complicated and really operationally annoying. Like if you're doing NLP properly, you need to do lots of different things, and it's lots of different steps, from even pre-processing, training, annotation, evaluation, all kinds of custom logic around it, and that's really annoying. That's a lot of work, and so I think often that's why people don't do it or don't do it properly, and then the project fails, and so that's also what makes a kind of LLM maximalist solution so appealing. And you also have a lot of operational complexity, you need infrastructure and so on, so that makes it also a lot less appealing. And finally, what you really need is a lot of NLP expertise as well, and that's the kind of expertise that you might not necessarily learn in university. It really comes from having solved a lot of these problems yourself and getting a good sense and a good intuition for how to take a larger business problem and break it down into machine learning components, how to develop data. That's all something that really comes with experience. So I think these are all reasons why we're doing less of the workflow that's maybe in a lot of cases much better and superior. And applied NLP specifically is a bit different because it really is project work. You're not just creating an artifact. You have an iterative process and you want to continue to work on this. And that can be tricky, especially even with coding assistants. And coding assistants, I would say, they are pretty good at a classic software 1.0 where you produce a code artifact, or like at least kind of, we're getting there depending on what you're doing. But if we're looking at the software 2.0, which is code plus data, there we have a whole other dimension, which is the data. And if you've ever tried to make a coding assistant engage with your data and look at your data, you might have noticed that it kind of is really trying to avoid that. And I think that makes sense because they're tuned for heuristics and they're tuned to create code and not be used as these data workhorse tasks. At least, they're trying to actively discourage you from using the models that way, and that makes sense. But the question is, well, how can we then solve it instead? Like, how can we make this easier and bring these agentic workflows that we're now able to use to software 2.0 and to a workflow with code and data? And this is all something that we've been thinking about a lot, and it's really what has been consuming all our development ever since coding assistants have become viable. And it's led to a new tool that we've been calling ELF. It's short for Explosion Large Language Framework. It was kind of a working title, and then the name stuck because it was short and the domain was still available. So that's that's how it's called. And it's actually one of the first times that I'm really showing this in a talk. And you can check out the documentation and beta website for more info. You can sign up for the waitlist to be notified when it's available. And early on, when we were developing it, it really became clear that it needs to integrate with existing coding assistants like Claude Code. We don't want to re-engineer any of that. We don't want people to use yet another tool. So we really want users to be able, within their coding assistant that they already use, to define these problems and to get feedback on their NLP solutions and really, have this embedded NLP expertise in the assistants and agents that we already use. And we also wanted to incorporate all of our knowledge and expertise that we've collected over the past 10 years or so, working on real-world problems and solving NLP problems, and make our coding assistant that we already use proficient at NLP. So basically, a virtual NLP engineer. And in this case, the first step is usually, well, you want to describe your project and what you're doing, and you want to create a project plan, break it down, and decide, okay, what are the next steps? And that's usually also one of the parts that's often really hard. And one central component of ELF and the workflow modules for different parts of the NLP development lifecycle. So we obviously have the project advice, the kind of first entry point into the process to break down the problem into something you can actually work on. There are workflows for defining your annotation task, defining the labels, which again also is often much more difficult than doing the actual annotation itself. Annotating data, writing custom workflows for annotation workflows that can then be completed by humans, but also, of course, by agents automatically. And there are also many use cases where maybe you first want to find out, is machine learning the right task? Do we even need that? Can we solve it with different heuristics, with match patterns, even with regular expressions instead? So that's an important step. And then you want to train models. You also want to interpret the results. What does it mean if the accuracy isn't improving or is improving like that? What does that mean for my next step? And there's also all kinds of other questions you might have about best practices, how to do something, sense checking your ideas. And these are all under the hood implemented as skills. And it's also something we want to be open sourcing once ELF is out of beta, because I think it can be very useful for everyone to add these additional skills to their coding assistant to make it proficient at NLP as well. Now, with all of this, there's one problem that we actually noticed pretty much immediately, which is when you're doing Vibe NLP, you need to run lots of things, and it's a lot more than you normally would if you're just vibe coding, where usually you're just writing code and maybe executing a few bash commands. That's kind of it. But for Vibe NLP, there's actually quite a lot. You want to train, of course. There's a lot of optimization, hyperparameter tuning, and so on. You want to analyze the results, the data, and all kinds of other things. Of course, you need to evaluate, or at least you should evaluate properly if you want to do it properly and do it right. There's all kinds of data transformation, data cleaning. You want to have tests that run. And then, of course, you want to develop the data. You want to create your annotation tasks, and then you want to assign auto annotation agents and make sure that works, that your data is created automatically and correctly. And then most projects also have all kinds of various scripts that are super custom to what you're doing that you also want to integrate somehow, and all kinds of other stuff like that you need to run as part of the process. So as I said, like this is what I mean by it being operationally annoying. It's like all of this stuff that we need to run, and all of these things are also, of course, interconnected, depend on each other, should run in parallel or in sequence, and so on. You have things like a GPU that might be nice to have available if you're training in certain situations. Then if you're working with data, of course, in practical use cases, your data might be quite sensitive, so you can't just send that to APIs, and you need to make sure that maybe it can't even be on the internet. And all the scripts and other custom stuff is often fully custom to your use case, so you kind of need to build that from scratch, or of course, you might have your coding assistant build it from scratch, but it sort of needs to integrate into the process. So how do we solve that? Well, I think the solution is infrastructure. We need infrastructure, for example, a Kubernetes cluster. And the nice thing about actually coding assistants these days is that they're pretty good at configuring infrastructure and like Terraform stuff and Kubernetes and things like that. So it's actually quite feasible for people, even without the deep DevOps and infrastructure expertise, to get something up and running and operate their own cluster properly, even if you only half know what you're doing. And that means that the user is able to host their own cluster on their own infrastructure, like either on a local workstation or in their cloud that they control, and the data can stay on there and doesn't need to be processed by our servers, because we also we don't want that. There's so many advantages of letting the user be in control of the code and data, and be able to also run things, which is kind of nice because you get all the advantages of a SaaS product, which is inviting people, having something online that you can log into, collaborate on, but also because you're operating your own cluster, the opportunity to script the app in Python, in code, in a language that you know, and basically do anything that you need to do. And the general processes that can run on a cluster like that, we divide it into three main categories. So one of them is tasks that are annotation tasks. So these are optionally can have a model in the loop. They start the Prodigy annotation tool or any other annotation tool, and then can let the user create data, review, or have an agent do it automatically. And then there's actions, which are basically any processes that run code and exit. So that could be training, but also pre-processing, conversion, evaluation, any computation that you want to do, optionally with a GPU if you have that available in your cluster. And then, of course, we have the agents, which are autonomous workers that you can assign to tasks, and that can complete the annotation themselves. And especially if you've gone through the process and you have a well-defined annotation scheme, that usually also leads to much better results when you're auto-annotating and having the agent basically create the data for you, which also removes a big part of the operational complexity and like annoyingness of the whole workflow. Now, when it comes to data development, there's a lot of best practices that you might be aware of, like you're probably supposed to be splitting up the work. You should run pilot projects and pilot annotations, decide how much overlap you want between humans and between agents, and all of this makes it much harder to orchestrate and difficult for small projects. So people often don't do this, and then the project doesn't succeed, and it's all annoying. And again, that's also why a situation that that completely avoids this is so appealing. But data is still probably the most, custom data is still the most scalable way to improve your system. So if we have a good workflow, we can take advantage of that. And that really changes things if you're in the same system and you're on equal footing with the agent. So you can do some of your own stuff, you can review, you can assign people from your team, you can assign subject matter experts if needed, and otherwise you'll be working alongside the LLM, not just with the LLM in the loop. And we found that this kind of collaboration between humans and coding agents was one of the most important aspects of making this idea of Vibe NLP and agentic software 2.0 work. So as an example, like if you've used our annotation tool Prodigy before, you might already be familiar with the concept of recipes. These are Python functions that configure workflows. So from annotation to data processing, training, and so on, with a nice decorator that defines meta information. And these are automatically turned into a CLI that you can use. And now in ELF, we can actually take this to another level, and we can also generate a UI automatically from that Python function. So essentially you, and of course your agent, is able to really script the SaaS application, which normally you're not able to do because nobody wants to run your Python. But here, you're running the Python on a cluster you control, and you have different entry points into the same functionality. And with agentic development, there are some people that think that, well, coding is now essentially free, and so does it really matter anymore what the developer experience is like? And who cares really what the interface is? It's all done by agents, so do we even have to worry about it? And I actually believe it's the opposite. I think scriptable and programmable interfaces and developer APIs are now becoming more important than ever, not less, because these APIs are the collaboration point between the human and the agent. So they really matter. And we've also seen that having well-defined developer APIs also makes it a lot easier for coding agents to navigate a code base and use it. And that also really highlights another important thing that we found, which is that the app and the developer API really need to speak the same language. And what I mean by that is, to give you an example, well, most productivity tools or whatever you have these days come with like this built-in chat assistant, and they're often pretty bad. And this really, I feel like this kind of adds to this whole sense of like the enshittification of the internet, having these like annoying chats everywhere that are kind of bad. And that's really something also we've tried to work hard to avoid. That's not how we want the collaboration experience to feel like. And to illustrate this, like you can kind of think of it like a centaur system. So a hybrid between humans and machines. And that's usually how people are imagining this. And people are imagining that you're kind of the head and powered by the machine. But if you do end up with a workflow or a situation where the computer basically tells you what to do, you go away, like click some buttons, do something, and then report back, you have the horse's head and the human ass. So that's why a lot of these workflows feel so bad. And you really don't want this. You want to be the one driving. And to avoid this, we need to make sure that there's really a shared interface between the app, developer API, agent, and human, and the same CLIs and APIs that you are using are also used by the agent. And that means that tasks and work can be handed back and forth in a very seamless way. So there's this kind of dumb take that we won't even need software anymore in the future, and AI will just write bytecode directly. But I obviously don't think that's the case. I think we still need software, and we also need to participate in building it. And because you need to make a lot of decisions along the way, and that's important. So you need to be driving, and you need to be involved. And this process of creation is very expressive. Like you can't just expect to know what you want up front. It develops as you go. The only way to get the computer to do exactly what you want is to be there and be involved in the process and be building. And I think we also still need machine learning systems, because there are a lot of systems where machine learning is objectively the right way to build a specific type of functionality. And so it's the right thing. We just need to make the right thing easier. And I think, I'm not saying that our supervised learning and, training your own models was perfect. I think we kind of got to a point where things were improving, but then everyone collectively got distracted by generative AI, and we never went and worked on improving these workflows. And I think there's a lot of low-hanging fruit and a lot that can be improved. And especially if we now have agents and coding assistants available that can guide us through the process and tell us what to do. And in instead of using LLMs as the classifiers, as we've seen, we can use them to create classifiers. So there's still a need for these types of systems and classifiers, by which I mean any kind of information extraction process where you're predicting something. This can be very useful. This can be a very reliable way to use your own data. So again, we just really need to make the right thing and the right workflow easier and as easy as using an LLM directly, because that's one of the main reasons why the sort of maximalist workflow has been so appealing to people. And because Software 2.0 code and data is really an iterative process and not static, and it's really specific project work, we also need to enable the collaboration between humans and agents and give humans the most efficient interfaces to participate in that process. So what can we take away from this? As we've seen, I think it's been obvious that LLMs, generative models, are really powerful, and a bit less obvious how to really best use that power in our practical work. And I believe one of the best ways to do this is to use the LLMs to build systems instead of just using them as systems and waiting for the one model to rule them all that will solve all of our problems. And for this, apps and developer APIs and agents really need to speak the same language, whatever that might be, if it's a developer API or something else. You need to be the one driving. You want to be the head, and not the machine, and you want to be in charge and participate in that building process. And the one argument for using LLMs as classifiers was that, well, it's just really easy to do. But I think we can be a lot more ambitious than that. We can aim for the absolute best result, and along the way, we can make that best result easier. Thanks. And yeah, if you're interested in ELF, you can check out the documentation. You can sign up for the wait list. And if there are specific things you want to see, I'll be around. I can also show you. We can hack a bit, and I can try out some things in action and type in some of your NLP problems, because we'd love to try it out and yeah, improve quickly and really help people solve more problems.